So let's take a look at finding some probabilities on the normal curve for values that aren't necessarily empirical. So we're not given a exactly 1, 2, or 3 standard deviations away. We have to find something for a z-score that's a little bit more exciting. So let's just come up with a z-score example. Before we had a 1.2, let's say z-score is 1.23. So you have a table that looks kind of like this in your packet. All of them are exactly the same. This one, it shows kind of what the curve looks like. It also has all the values kind of in a table here that has different colors delineating which one is which. Yours doesn't have the colors, doesn't have the curve, but the values would all be the same. So what we do to find the area to the left of 1.23, table will always tell you the area to the left. So you always have a picture here. If they have a picture, they'll have it shaded like this to show it's really finding the percentile for that z-score. And the cool thing about normal curves is that no matter what the standard deviation and mean are, if the z-score is the same for two different curves, the area to the left of that value will always be the same. So all you have to do is calculate the z-score, look it up on the chart, and it will tell you how much area is to the left. So here, if we have z equals 1.23, here's how you do it. On the left side, you look for the first place and then the first after the decimal. So 1.23, here's 1.2. And then we're going to scroll over to 0.03. So the reason for that is that you added the two together. So 1.2 plus 0.03 is 1.23. You don't have to know that. You just have to be able to find it on the chart. So 1.2 and then scroll over to 3. That's right here. And they tell us that 89.07% of the area underneath the curve is to the left of that value. So we look further to the right, like we go to 3.49, we see that almost 100% of the area is to the left of that, because 3.49 is going to be right there. So pretty much all of the area is to the left of that value. Let's try another one that often trips people up. Let's try z equals 2.05. So 2.05, that's a z-score that's going to put us, I'm going to get rid of that guy. So it's going to put us past 2, just barely. So here is our mean, here is 1 standard deviation away, and then 2 would be over here. So 2.05 would be just past there. So we're trying to find all of the area to the left of that z-score value. So 2.05, the reason I bring this one up is because a lot of people start by looking for 2.5, but we want 2.0. So we're going to find 2.0, and then we'll scroll over to 5, which is right here. Looks like 97.98% is going to be to the left of that value, or 0.9798. You can give a probability as a percentage or as a decimal. Either one's fine. So this table shows all values starting at 0.5. Sorry, excuse me, at 0 for the z-score. So where would a z-score of 0 be? It's kind of worth thinking about that. A z-score of 0 would happen right at the average. Right? And you expect 50% to be to the left, which is why exactly 50% is there. So it starts there and it moves all the way over to 3.49, and beyond that, pretty much everything's going to be 99.99% that's to the left. You'll never get to 1, but if you went far enough out there, it would have a value very, very close to 1. So these are all values to the right side of the curve. You also have a sheet in your packet that has the negative z-scores. So a negative z-score just means that you're on the left side of sigma. Or sorry, of mu, of the average. So these should all be values less than 50%. So if we had, for example, if we do our z-score calculation, x minus the average over standard deviation, and we get a number that's I don't know, negative 2.3, yeah, let's just do 2.3. So I'm going to find negative 2.3, there it is right there, and because there's nothing else along with it, I'm going to go to the 0 column, which is right here. So it looks like there's about a 1% chance that you have an area to the left of negative 2.3. Remember, these areas are always to the left. Negative 2.3 is pretty far out there, so that small value makes a lot of sense. So let's try some problems with these. So here we have the z-score for an ACT score of 18. Well, that's not going to be too bad because the average is 18. So make a hypothesis. What is that z-score going to be if we're right on the average? How many standard deviations away from the average are we? It should be 0. Well, let's do the calculation. So z will be our x value, 18, minus our average, which is 18, divided by the standard deviation, which is 6. That's 0 over 6, which is indeed 0. So if we go to our chart, which you can check on your sheet if you wanted to, 0.0 looks like 50%. So you have 50 percentile. 50% of the data lie below that z-score of 0. So let's try a little bit more exciting. This time we have a score of 20. So I'm going to do the z-score formula. So 20 minus our average, which is 18, divided by our standard deviation, which is 6. Looks like that's going to be 2/6 or 1/3. So then, asking what percentile corresponds to that score. 1/3 for a z-score is about 0.33 repeating. And if we want to find the percentile that corresponds with that z-score, all we have to do is go to 0.3 and then rule over to 3 right here. Looks like that percentile would be about 62.93%. That's it. So finding areas to the left of values, really not that hard, just using the table here. You need someone just kind of show you how to do it, and then you can do it on your own just fine. So here's another example, different distribution. So they're saying the length of 10th grade girls' hair is normally distributed with an average of 10 and a standard deviation of 4. So they made the curve for us here, which is nice. They ask for the z-score for hair of length 16. So z would be 16 minus our average, which is 10, divided by our standard deviation, which is 4. Looks like 6/4, which is 3/2. Okay, so that is our z-score. They want to know the percentile as well. So the percentile is going to be the area to the left of that value. 3/2 is 1.5. So I'm going to go back to our chart, which I think I have right here. And that won't go quite high enough. Let's go to the official one. So 1.5 was our z-score. So 1.5 and then all the zeros, because we want to get that value for exactly 1.5. Looks like 0.9332, which makes sense because a lot of the area lies to the left of it. Like I said, 0.9332. So if you were talking specifically about percentiles, you might say that this person's in the 93rd percentile. Cool. Percentile. All right, let's move on. So once again, here we're talking about these girls' hair. So suppose the z-score for a particular 10th grade girl's hair is negative 2.65. They want to know the percentile. So this part, like, they already did half the work for us. They found the z-score for us. We don't know what the length of the hair is, but they tell us the z-score. So to find the percentile, it's negative, so that means we must be on the left side of the curve somewhere. And we want to find the percentile, so the area to the left. So negative 2.65, here's negative 2.6, here's 0.05. Looks like there's a 0.4% chance that they're going to find, that you would have hair that is less than a z-score of negative 2.65. So 0.004. So about 0.4%, very small. So one more with a twist here. So the data for the length of 10th grade girls' hair, once again, is normally distributed with an average of 10 and a standard deviation of 4. There's our 10, 14, here would be 18, and then on the left, 6, and 2. So what percent of girls have hair shorter than 15 inches? So 15 is not one of the values on here. 15 would be like right over here somewhere. And what we're going to do is we're going to shade in everything to the left of 15, because that's the area that we want. So there's the area right there that we want. And to get that area, we just have to convert to a z-score. So our z-score is going to be 15 minus 10 over 4. Looks like 5/4, or 1.25. So now all we have to do is go to our chart and figure out what 1.25 corresponds to. I'm going to have to go back to our big chart here. So 1.25. Here's, that's negative. So 1.2, scroll over to 5 right here. Looks like that's 0.8944. Here we go. So 0.844 is the percent of girls, so 84.4%. Have hair shorter than 15 inches. Next up, what percent of girls have hair longer than 7 inches? So for longer than 7 inches, this is kind of interesting. 7 is going to be over to the left somewhere. They want to know they probably have longer hair, so that's going to be everything to the right. So this is where you kind of have to use your brain a little bit. Our z-score for 7 is going to be 7 minus 10 divided by our standard deviation, which is 4. So it looks like that's negative 3/4, or negative 0.75. So if we go to our chart and find negative 0.75, I'll have to look on the negative side right here. Negative, what do we say, 0.75? Yep, negative 0.75. So negative 0.75 is what I'm looking for on my negative chart here. So here's negative 0.7, and then we scroll over to 0.5. Looks like 2266. But the trick with 2266, let me put this down here. That is the area to the left. I want the area to the right. Well, what do we know about curves? What does it all add up to? That's up to 1. So then this shaded area right here is going to be 1 minus 0.2266. Maybe grab a calculator for that. So I'm going to do 1 minus 0.2266, and that gives me 0.7734. So whenever you see a more than or a less than, just make sure that you're getting the right part of the curve. And let's look at this last problem. What percent of girls have hair between 8 and 13 inches? Let me get some space for myself here. So between 8 and 13. So here's our curve. Average is 10 right in the middle. Here's 8 somewhere. And here's 13. So let's figure out how we can do that. So all the chart tells me is areas to the left. Well, I argue if I can find the area at 13 and the area at 8, I should be able to find that area in between. Because 8 is going to give me everything over here. 13 is going to give me everything all together. So if I find the 13 and then subtract the 8 off, that should work just fine. Okay, so let's find the area at 13 first. So we have to find the z-score. 13 minus 10 over 4. 13. So that'd be 3/4, or 0.75. And at 8, so we're trying to find the area to the left of 8. That's going to be z is 8 minus 10 over 4, which is negative 1/2. So let's do the 3/4 z-score first. So we're going to go back and find our z-score. So 0.75 was the value we had. So here's 0.7. Got to go to the positive one again. 0.7's right here, and then 5 is right there. So 0.7734. So that's 0.7734. That's our area to the left of 3/4. And then negative 1/2. So this one I can use the negative one for. So negative 0.5, and then it's all zeros. Looks like 0.3085. So 0.3085. So now we have x. That's our x. And this guy up here includes the stuff we actually want to use. So what we're going to do is take that value and just subtract x. So it'll be 0.7724 minus 0.3085. Grab our calculator for that as well. So 0.7724 minus 0.3085. And I get 0.4639. So that's the percentage of girls that have hair between 8 and 13 inches. Kind of cool. So that's all I've got for you today. The homework sheets are really quick, so you are going to want to try all of these because it's not going to take you all day. 7.2a is mostly about z-scores. 7.2b is about some rudimentary calculations, just some simple stuff. And then C kind of puts it together. So do take a look at all three. I'll be checking that when I get back. Other than that, you got the rest of the hour to work on homework. I love you guys. That's why I'm here. Have a great day. See you tomorrow.